In this video, I'll be teaching you how to do hyperparameter optimization. Sounds like a complex word, but it's very simple to understand. So let's get started. I'll talk about hyperparameter optimization and the techniques that are used to perform hyperparameter optimization. Then I'll get into the coding part. So I'm gonna write it here. Hyperparam optim. I got. Okay, I'm just gonna do optimize optimization. Or okay, ran out of space. Just so so I want to talk about hyperparameter optimization. So what hyperparameter optimization optimization does is that, so whenever you like build a model like this and you will define your object, or wait, like linear, like regression, you're defining like the library, like the object, and you're putting it into a variable. So regression, and inside these parentheses, uh, there are these hyperparameters. These parameters are called hyperparameters, and if you change them according to your like data set, you would get good results. And you already have these default parameters that are already in your what do you call it, model. So you have to, if you can change them to get like higher accuracies, and this is where hyperparameter optimization comes in. So inside these what do you call it, those parentheses, there can be lots of variables, like lots of them. So you there has, because, and you can't like memorize like a lot of them, like, I mean, how can you do that? And a way to do this is just probably use techniques called I'm gonna have some space here, is to use two techniques. The first technique is grid search. um Grid search, and the other one is random search. Right, guys, the first one is grid search and the second one is random search. So what the grid search does, so both of these searches, what they do is that first you make a variable. So you create a variable that has dictionaries, that has a list of dictionaries. And for example, so I'm going to create a variable. You can create a variable called param, which stands for parameters. And it can have a list of dictionaries that define these, what do you call it, these parameters and the values, and the and you can put those values and for these parameters, and you give you give that parameter value variable to your grid search algorithm, and it does these calculations, and you print out those, what do you call it, those best parameters and best accuracy that you can get with those best parameters. And you to basically like get the then it will it takes some time to like print out the takes some time to do the calculations, all that. After those calculations, you get what do you call it, a list of parameters, uh like this or something. And then it gives you a best accuracy, and you can have like 95%, and for 95% you need to plug in these parameters to actually uh what do you call it, to actually get a higher score. So now let's get into the coding part. So now, as you guys can see, I already implemented a kernel as a support vector machine, as you guys can see. um I already have these default parameters and whatnot, and So we need to, so if you guys look at the accuracy, it only has 94%. I'm gonna use grid search in this video and maybe random search in the future videos. People say that not future, like grids, random search is more popular, more better than grid search. But I can't agree with that. So I'll talk about that in the next video when I do about with the topics about random search. For this video, I'll be doing grid search. Um, so first, so as you guys can see, that's 94%. So we want to make it go higher. So that's what I'm gonna do now. First, I'm gonna import scikit-learn, which has lots of what do you call it, libraries that you can use to, for machine learning. So probably the best library that I think is my favorite. So now you have to import. So from scikit-learn.model selection is what you use to train, test, split your data set. So it's that same thing, and you from there you import grid search CV. And now we have to, well, actually build actually, what do you call it, you actually have to have the variable. So yeah, so that's what I'm gonna do now. I'm gonna create a variable called parameters, right guys? Parameters. And this parameter variable is going to store all our dictionaries, which represent each of the, what do you call it, the parameters. So that's what I'm going to do now. So to make a dictionary, you have to have these brackets. I'm going to have two dictionaries. Right, guys? So I'm just going to, no, what's that? No. So I'm going to do this. And inside here, I want to have another pair of brackets. Like, well, yeah, I think this is, well, okay, I guess. So now you have these, what do you call it, this bracket. Inside here, you're just gonna write your, I don't know, your dictionary stuff. Um, you know what? I'll just rather have them be close to each other. Okay, so I'm gonna have another one right here. So two dictionaries, and the first one is gonna is a what do you call it, parameter called C, right? So it has to be in double quotes C, right guys, and with columns. And this is how you create a dictionary. So inside these brackets, you put the what do you call it, the certain values for this parameter. Like in a dictionary, this like a word has meanings, kind of like this. That's what a dictionary is in programming. So here I'm gonna have different values like 0. Like 25%, 50%, and I'll have 0.75, 75%, finally 1%. Great. So we have our, you know what, I'm not gonna, you know what, I'll just do one instead of like doing that. So now we have, well, one. So why am I having two dictionaries? I can put all the dictionaries like one list, but why am I having two dictionaries? That's because in the kernel, you see this guy's kernel. Where is it? Okay, so as you guys can see, there's kernel, right? I'm gonna delete all of this so you guys can see. So there's this variable called kernel. If you guys see here, come on, where is this? So as you guys can see, there's this kernel. So I'm just gonna do run all. So what is that? And well, not this one. So you see this kernel, this is like set into default values, and there's two types of kernels, RBF and linear. So for RBF kernel, there's this another parameter that goes with this RBF kernel if you apply it, called the gamma. It should be here somewhere. Yeah, gamma scale. See that, guys? So for that, that's why I'm having like two dictionaries instead of one. If the RBF kernel didn't have that gamma with it, then I would just put all of them into one big I don't know, list like that. So here, just avoid this Can I just clear output for a sec? Okay, good. So now I'm gonna just copy and paste this one for the second dictionary, right, guys? And oops daisies. Okay, so just copy and paste it here. Boom. Great. And this one should be in brackets, by the way. Good. So now I'm gonna create another dictionary inside this list. That's called kernel, of course. Kernel, right, guys? And this is going to be equal to linear, which is going to be our first set of dictionary, and RBF is going to be our second set of dictionary. So here, I'm gonna write in brackets, because that's how you define like the values for your dictionary. Here, I'm gonna write linear, and since linear doesn't have the gamma, I'm just gonna leave it right like that, and I'm just gonna copy this. I'm gonna paste it here, except that the linear is going to be RBF, right? And we're not complete with this part. I forgot that. So, okay, something is weird. Uh-oh, guys, we did an error. We got an error. Okay, so that's why. Okay, delete this. So, now, for RBF, I'm just gonna go inside the, so for RBF, you have to define like the gamma thing, the gamma dictionary. That's what I'm gonna do now. Create another dictionary called gamma, and this one is going to be beside brackets, and I'm gonna fill in with every possibility that I can do. 0. Oh no, 0.2. I want to do 0.3. Then I want to do 0.4. I'm gonna go all the way to 1. 0.5 and 0.6 and 0.7, 0.8, and finally, no, not finally, 0.9, and finally 1.0. I'll just leave that at 1, but I mean, who cares? So, well, great. Now we actually will build our like the grid search thing algorithm and actually apply it. Apply it. So first, I'm gonna make a variable called grid search. I'm gonna set this grid search equal to grid search.csv, our library that we imported, and here inside here I'm gonna have all like a group of parameters. So the first a parameter I'll be specifying is the estimator, which is our model. Set this estimator equal to our classifier. Good. Comma, and here I'll put param, which is a grid. Okay, not that. Right? Set this equals to our parameter variable that we just created. Right? So now you have to have like a scoring metric to actually see the accuracy. So I'm gonna specify here. I'm gonna specify this as accuracy. And then I'm gonna set a variable called CV, which you might recognize from my XGBoost tutorial. I used it for k-fold cross-validation. It just specifies the training fold that you have, like the testing fold, not training fold, testing folds that you want to like actually to avoid overfitting. I'm gonna set this equal to 10. It's like a default value that most AI experts use. So finally, there's like another parameter, jobs, not jobs, jobs. I'm gonna set this equal to -1. Great. And yeah, that's it with the building part. No, okay. So now we have to, well, actually get the parameters and the accuracy, which is what I'm gonna do now. First, I'm gonna like actually transform it before doing that. So like, first I'm gonna bring out our grid search, and then I'm gonna do, no, not that, do famous fit function, and I'm gonna feed it to the X train as well as the Y train. Boom. Now we can start, well, getting the accuracy. First, I'm going to create a variable called best accuracy and best parameters. So best accuracy is going to equal to a library. So there's this library in Grid Search. It's called best score. It's a attribute, right, guys? So I'm just going to import here grid search dot best score. This one, right, guys? And that's all you have to do. It's easy. So now I'm just gonna copy this grid search, paste it here, except that the score is going to be params, which stands, like, not params, which stands for what do you call it? Parameters. So now we have to print, right, guys? We have to print the what do you call it? Our best accuracy and best parameters that we use for that best accuracy. So I'm gonna double quotes. I'm gonna write best accuracy. I'm gonna use to print the accuracy. Here, I'm gonna want the value as a float, 2f, and here I want to do. So now, oh wait, no, we have to make the percent sign for actually writing a format. Here, I want to add the best accuracy, best accuracy. I'm going to times this best accuracy by 100 so we get a much easier to read results. So 100. All I'm going to do is copy and paste, except that there's not going to be times 100, and best accuracy is going to be best parameters, right, guys? And there's not going to be, we're not going to assign it a float variable, so none of those float thingy. So here all we have to do is just put a comma right there. So, and then I'm going to change the accuracy to best accuracy to parameters. Great. So if I run this cell, see what we get. Oh, so the best accuracy that we can get is 97.27. That's our given parameters list. We can it tells us that C is equal to 0.5 and the kernel is equal to linear, and if we apply this we get 97% accuracy. So this is how you implement this what do you call it, the grid search for hyperparameter optimization. So yeah, see you guys later on the next video. Bye guys.